8:30. Originally I was going to have my colleagues run around and give microphones to people, but I think that's too much running. I was told that if we fill this room, it's 700 people, and we have standing room in the back, so well done all. So I suggest you do like we do in the Hall of Lecture series, you come up and you can ask a question, one of the mics. So you can line up on the sides and then ask a question from the mic. And I would ask that there's a lot of people here, ask a question, don't give a speech. So. Yeah. And I'm not very good at that either. You know, less than 20 seconds to get the question. Okay? Thank you all again for coming, and I'll give Dr. Hansen will field the questions.
Here in Omaha, Union Pacific Railroad is based, and we should know that they had significant layoffs in the last 2 quarters due to lack of business with their coal cargo. So there is a cost to this. I think we should realize that. But my question is this. Your theory about this disaster is based upon your models. Your models have mostly been wrong for the last 30 years. So how do we know that this impending disaster and your models are going to be correct 70 years from now when everybody in this room is dead?
Yeah. So if you look at, you could look at the paper that we published, and you will see that it's not based on models. It's based on the combination of the Earth's history, called paleoclimate, on climate models, and thirdly, on observations of the real world. And you know, the physics is actually very simple. When you add carbon dioxide to the atmosphere, it absorbs heat radiation. It's like a blanket. So that makes the planet temporarily out of energy balance. More energy coming in from the sun than heat being radiated to space because of this absorbing gases. Well, we can now measure that planetary energy imbalance, and it's coincidental that I have sitting up here a slide. You know, the atmosphere of the Earth is very thin. It has a very small heat capacity, but the ocean is 2.5 miles deep. On average, it has a huge heat capacity. So when the planet is out of energy balance, most of that excess energy is going into the ocean. And we now, beginning about 15 years ago, several nations have cooperated in distributing more than 3,000 floats around the world's ocean. They dive down to a depth of 2 kilometers and come back to the surface and radio to a satellite their measurements. And this allows us to measure how the heat content of the ocean is changing. And what we find is that it's steadily increasing. It's increasing, and this graph just goes to the end of 2008, but the data goes up to the present, and that increase is continuing and slightly larger in recent years. That rate of increase, which is about 0.6 of a watt per meter squared averaged over the entire planet, doesn't sound like a lot, but it's equivalent to the energy in 400,000 Hiroshima atomic bombs per day, every day of the year. That much excess energy is going into the ocean, and it's warming the ocean, and that ocean is now melting the ice shelves. We're able to measure all these ice shelves around Antarctica and Greenland. They are melting, and now the masses of the ice sheets are beginning to shrink, and we're measuring that very precisely with gravity satellite. So it's not a complicated story. It's a straightforward one, and it's one which is it's scary just because of the inertia of the system. It wasn't easy to get these massive things to begin to change, but they are beginning to change at increasing rates. So it's not some models that we dreamed up. There's a lot of well-established physics and observations behind it.
Jeff, you mentioned earlier about the increased rapidly melting ice cap on Greenland and the Arctic ice cap. That drives lateral curves. The cold water current makes the Gulf Stream turn over and warm Europe. What's going to be the ramifications when the Arctic ice cap finally does melt and the lateral current driver stops, and now the Gulf Stream is going to go what? Straight up over the top of the North Pole, come down through the Bering Strait?
No, this actually, the title of our paper was Ice Melt, Sea Level Rise, and Superstorms. And I started the research on that paper almost 10 years ago when I read papers by a field geologist who was analyzing data in the Bahamas and Bermuda for what happened during the prior interglacial period, which was went from 130,000 years ago to 116,000 years ago. Well, that period was about 1 degree warmer than now. And it did, near the end of that interglacial period, sea level went up rapidly by several meters to a height of maximum 6 to 9 meters above today. And there were very powerful storms because the North Atlantic cooled suddenly as this overturning Atlantic circulation shut down. So it cooled several degrees, while the tropics was a degree warmer than now. And that's exactly the scenario that we're going to get in the future if we allow the melting from Greenland to continue to increase. It will shut down that Atlantic overturning circulation. You'll get cooling of several degrees in the North Atlantic, but the tropics will continue to get warmer. So the temperature gradient from the tropics to the North Atlantic gets much stronger, and that's what drives stronger storms. So all hell breaks loose in the North Atlantic. And Europe will actually get slightly cooler, a bit cooler because of this cooling in the North Atlantic, while the rest of the planet, most of the planet, is getting warmer. And it will be, and unfortunately, if you shut down the Atlantic AMOC, overturning circulation, that does not restart it takes 300 to 400 years for that to restart. So for any time scale that the person would care about, Europe is in that state, and we have strong temperature gradients, and we have strong storms, so we don't want to go there. But to avoid going there, we're going to have to phase out fossil fuel emissions rapidly. But as I say, the tragic thing is, it doesn't cost anything. You know, this Citizens Climate Lobby funded an economic study to see what would be the effect if we had a $10 a ton CO2 fee that went up $10 a ton each year. At the end of 10 years, it's $100 a ton, and it's $1 a gallon of gasoline. But it's about $1,500 dividend to each person. So you pay attention, because, you know, some people will lose money, especially rich people. They have a bigger carbon footprint, they have bigger houses and travel more. But what does it do to the economy? It actually increases the jobs by several million and increases the GNP. So the claim that, oh, we can't afford to deal with this is total bullshit. You can actually improve, and the reason is very simple. An economy is more efficient if prices are honest. And right now, we're subsidizing things. We shouldn't be subsidizing fossil fuels. We shouldn't be subsidizing other energies. We should let the market make those choices. And if we do, the economies are actually more efficient. And so we can solve the problem, but we have to have politicians who are willing to say it's not just a slight twist to business as usual. We've got to actually do something that is required for the sake of young people.
My question is actually very tied to that. Have you ever thought about maybe using the carbon tax that would be placed on the fossil fuels as subsidizing renewable energy sources? Because that would go directly to the source that you're hoping to switch to. Seems like it would be a much more effective way than redistributing it to citizens.
Yeah, well, that's when I actually slightly mischaracterized Boxer Sanders. What they proposed was 60% of the money to the public, 25% to reduce the national debt, and 15% to subsidize renewable energies. I don't, that's not, an economist would agree, that's not the most efficient way to do it. Let the renewables compete with energy efficiency, with every other possibility. As that carbon price gets higher, people need energy, they're going to do something. The market will help find the most economically efficient way to do it. We shouldn't predetermine what the answer is. I mean, you can do that. And, you know, in a democracy, it's quite all right to say, well, I don't care about the cost. I want this energy to be our energy source. And that's what some people believe. And I don't agree with that. I think we have we have to have a level playing field. And economically, economists would say that's the best thing to do. But you don't have to do what economists say. You can say, okay, it's a democracy and a majority of people want to do this, then you could do that.
Hi. What's up with greenhouse gases? I mean, what is the physics that actually makes carbon dioxide a greenhouse gas, but not oxygen, not nitrogen? I mean, what's actually, is it absorbing the heat? Is it reflecting the heat?
It's just a matter of the nature of the molecules. So it's a question of how tightly bound the different atoms are in the molecule. It so happens that the amount of energy that you need in order to make a CO2 molecule vibrate or rotate is the amount of energy contained in a photon, which has infrared wavelength. And so most of the gases will absorb someplace, but the sunlight, the sunlight has a spectrum that peaks at visible wavelengths, and then the heat radiation from the Earth is about 10 times longer wavelength. It peaks at about 10 microns. So it depends on the energy of these bonds in the molecules. So, and it just so happens that water vapor is the strongest absorber. It absorbs over almost the entire infrared spectrum, but just happens to have a band in the middle where water vapor does not absorb, and CO2 does absorb there, and methane absorbs partially in that same band. And so they kind of fill that window. So therefore CO2 and methane turn out to be effective in that they're complementing water vapor.
So that's a fact as opposed to speculation.
Yeah. Oh, yeah. No, it's very well understood in terms of the atomic physics and in terms of the laboratory measurements. And the laboratory measurements were first made in 1850s by John Tyndall, Irish physicist who remarkably made a prediction. He concluded, based on these measurements of CO2 in the laboratory, the first measurements that were made, he speculated, well, that the ice ages were due to changes in the amount of CO2 in the atmosphere. Turns out he was right. In our paper, we show why, because when the amount of CO2 held in the ocean is biological material and otherwise depends upon how fast this ocean is overturning. And so that's what that changing rate of ocean overturning changes the amount of CO2 in the atmosphere, and that's why the ice ages would go from interglacial to glacial. But he had a remarkable insight 150 years ago.
Dr. Hansen, I really enjoyed your presentation, and I was just wondering, what are ways that people can practically try to work to reduce emissions besides stuff like trying to drive less and recycle and reuse things? Is there any other way that people can get involved in trying to help with this problem?
Yeah, you know, some of the things, I don't want to discourage people from riding a bike instead of driving and the various things like that, but I point out that even if you persuade millions of people to do that, one of the effects is to reduce the demand for the fuel, which makes it cheaper, and someone else can buy it and burn it. So that's why we have to have this rising carbon fee, because otherwise you can't solve it with your personal actions. However, but those personal actions will then make you money once we do have a carbon fee, and if we're giving a dividend. But there are some actions you can take that don't have this negative feedback. And one example is become less of a meat eater and more of a vegetarian. You know, you don't have to totally become a vegetarian, but if you just move in that direction, you've done something, you've put less pressure on the land. And that I don't see any negative feedback from that. So that's one suggestion.
So this evening, before I came here, I talked to a couple of employees who really had no idea what this was, and I explained to them, and they became very fatalistic in where we're going, what can they do. It becomes very overwhelming. How do you get that conversation to happen so that people feel like they can be empowered?
Yeah, that's a good question. There are a lot of people who feel that, gee, this system we've had going now for a couple of centuries. We went from wood to coal to oil to gas, and now we've got some countries going back to coal, India and China. But those things change slowly. Over several decades it takes to move from one fuel to another. But the studies do show this. There's a study by Regional Economic Modeling Incorporated which showed that an increasing carbon fee at the rate that I mentioned results in a 30% reduction in CO2 emissions in 10 years and about a 55% reduction in 20 years. So if you actually got the incentive out there, economic incentive for businesses and entrepreneurs and individuals, it actually would work. And I've met with people I call the captains of industry. And they're the people who, people who say, oh, they're part of the problem. But they actually have children and grandchildren, and they are willing to, and actually, in some cases, eager to be part of the solution, but they say the government has to give them the economic incentive because their first duty is to their stockholders, and their own salary depends on that. So if the fossil fuels are the cheapest way for them to make money, then that's how they will do it. That's why we have to get control of this, and it's going to be difficult. This is why I would try to challenge Warren Buffett to to speak out, he and Bill Gates agreed that there is a climate issue and it's a threat to young people. Now, they know enough about the way economics works and the way markets work that they should be willing to support a rising revenue-neutral carbon fee. And without that, you can't really solve the problem. I forgot your question. There was something more I was going to say. Sorry.
Overcoming fatalism.
Oh, the fatalism. Yeah. So, so the captains of industry, you know, want to have, so our political system is not providing that to they've got to provide the incentive for